Lesson 6.7 is geometric sequences. So we're going back to this idea of sequences. Remember, a couple chapters ago, you did arithmetic sequences, where we had a list of numbers where we were adding 2 each time, or adding 7 each time, or taking away 8. In this case, if you think about what we've been talking about with exponential functions and multiplying by the same factor, we're going to have a sequence where we're always doubling, or always tripling, or always being cut in half, that sort of thing. So our learning goal for today is I will extend and graph geometric sequences So what this means is it'll give you a sequence where it says extend. It'll say what are the next 3 terms. You'll be able to do that. And then I will write equations for geometric sequences. So those are our goals for today. So starting off with our geometric sequence, what we're looking for here is we're looking for a common ratio. So for example, if I had this list, here's a geometric sequence. And if I look at this, you can see that I'm multiplying by 5, multiplying by 5, multiplying by 5 to go from term to term. So that is what my sequence is. It's multiplying by 5. And this factor that we're multiplying by over and over is what we call the common ratio. And the reason it's called that is because if I take this term and divide it by the term before, I get 5. If I take this term and divide it by the term before, so 25 over 5, I get 5. 125 divided by 25 is 5. So that's why we call this the common ratio. When you set up a ratio of one term over the term before, you get the same thing each time. So the very first thing that you're going to need to be able to do is just extend these sequences, which means if I start with, we have position and term. In position 1, I have 3. Position 2 is 9. 3 is 27. 4 is 81. If I asked you to write the next 3 terms for this sequence, first we would have to see what that common ratio is. 9 divided by 3 is 3. 27 divided by 3 is 3. 27 divided by 9 is 3. 81 divided by 27 is 3. Which means that our common ratio, or the thing that we multiply by over and over, is 3. So the 5th number in this sequence needs to be 81 times 3, which is 243. And I'm going to keep going. For the next 2, I'm going to do 243 times 3, which I actually don't know off the top of my head. 729. And then my 7th term would take 729 times 3, and it's 2,187. So these are the next 3 terms in my sequence, and I found those just by multiplying by that common ratio. Our next example has to do with graphing. So we want to graph the sequence 80, 40, 20, 10, 5, etc., and see what we notice. So I need to graph this. I'm only going to have positive numbers for my x and my y. Let's see, let's do 10, 20, 30, 40, 50, 60, 70, 80. Because that would just be ridiculous to count all the way up to 80. So we're going to count by tens. And then this will be my first term, second term, third term, fourth term, fifth term, sixth term, etc. So 80 is my first term, that's up here. 40 is my second term, that is going to be right about there. 20 is my third term. 10 is my fourth. 5, and if you look at these, I'm not going to connect them with a line because I don't have a 1 1/2 term or a 1 1/3 term. So I'm just going to leave these as discrete points. But if you look, you'll see that they tend to be sloping down, and this actually looks like an exponential decay function, the way that it starts off dropping a lot and then it kind of tapers off. So what we should notice here is this looks like an exponential curve. And all of our geometric sequences are going to be making exponential curves. In this case, you'll look, our common ratio, we're dividing by 2 or multiplying by 1/2 each time. So this would be decay because our growth factor right here, if you think about it in terms of decay, is actually a decay factor because it's less than 1. So this is going to give us an exponential decay function. So that is how we're going to graph these. Just remember, it's really important that you don't connect the points for a sequence because this is discrete. So now that I know what a geometric sequence is, we want to work out what the basic formula for a geometric sequence is going to look like. And we're going to do that in a similar way to how we did it with arithmetic sequences. So remember, n represents our position, and a sub m, n represents the value of our term at that position. So if we're at position 1, the term would be a sub 1. So using numbers, let's say that our first term is 2. So let's just make our first term 2. So right now I just have a sub 1, that's term 1. For our second term, which we call a sub 2, let's call our common ratio 3. Let's just say we're going to multiply by 3 every time. This would be 2 times 3. I'm going to call that 3 to the first power. Or a sub 1 times r. So our common ratio is r. For my third position, that would be term 3. This would be 2 times 3 times 3 again, or 2 times 3 squared. Or another way of saying that would be our first term times our common ratio squared. Our fourth term would be a sub 4. That would be multiplying by 3 again, so this would be 2 times 3 cubed, or my first term times my common ratio cubed. And you should be able to see a pattern here then, which means when I'm on my nth term, so any term out there, that would be term a sub n. This would be 2 times 3 to some power. So let's look at how our exponent compares to our position. For my first position, I don't even have, this would be like 3 to the 0 power. For position 2, my exponent's 1. For position 3, my exponent's 2. 4, it's 3. So it looks like my exponent is 1 less than the position number. So I would call that n minus 1. Or just using general terms, I take my first term and I multiply it by my common ratio to the n minus 1 power. So this is where my formula is going to come from. Okay, the video cut out on me right when I was doing like the most important part. So anyway, we were at this point where we have our a sub n. A sub 1 is r to the n minus 1 power. So our nth term is going to take our first term and multiply it by our common ratio to the n minus 1 power. So this is the super big important formula that we're going to want to use for this section. Let's use that formula then to come up with a way to find my nth term here. So this is my position number, 1, 2, 3, and the value at that position. So my first term is 160, my second is 80, my next is 40. I want to know what is the value of a sub 6, or what would my sixth number in this list be? And of course that wouldn't be too hard to figure out just by continuing to follow my pattern here, but let's use the formula to do it. So the first thing that we need to do is remember the formula. A sub n equals a sub 1 times r to the n minus 1 power. So what I'm going to need to find is my first term and my common ratio. My first term is easy to find. That's 160. It's given to me. But I also need to find that common ratio, or what I'm doing to each term to get the next. So if I look, 80 is half of 160, 40 is half of 80, so it looks like I'm multiplying by 1/2. So when I put that into my formula, a sub n equals my first term, which is 160, times 1/2 to the n minus 1 power. So this formula is going to describe this sequence right here. That means then if I want the 6th term, I would do a sub 6 equals 160 times 1/2 to the 6 minus 1 power, or 160 times 1/2 to the 5th power. So on my calculator, I don't know if you can see that, I will do 160 times 0.5, that's just the decimal form, to the 5th power, and I get 5. So if I continued this sequence out, my 6th term would be 5. Okay, so the last thing I want you to do is this on your own. We have this sequence, 6, 12, 24, 48, 96, ... It's going to go on forever. And I want you to write the equation that represents this geometric sequence. So pause, do it, and then turn it back on to check. Remember that our basic formula is a sub n equals a sub 1 times r to the n minus 1. I would suggest as you do your homework that you write this down every single time until it's totally stuck in your head. Then I'm going to look up here at my sequence. I know that my first term is 6. And to go from 6 to 12, I multiply by 2. 12 to 24 is multiplying by 2. So my common ratio, or r, is going to be 2. So that tells me that a sub n equals my first term, which is 6, times 2 to the n minus 1. And that's it. You're done. That's the whole formula that describes the sequence. If you wanted, like, say, the 10th term, then you'd plug in 10 for n. You would multiply this out, and that would tell you the value of your 10th term without having to actually multiply by 2 10 times. So that's it for this section.